Okay, so we're going to take a detour today, and we're going to talk about Chapter 20, Lesson 3. And this is the only lesson from Chapter 20 that we're going to do for now. Okay? And this chapter is all about the perimeter and area of complex figures. And our learning goal today is to be able to find the perimeter and area of complex figures. Complex figures sounds really complicated, but all it means is that it's shapes that are not just like a rectangle or a circle or a triangle. Okay, those are not complex figures. Complex figures are ones that are maybe like what we saw in our homework yesterday, a rectangle plus a triangle. Okay, or sometimes you guys have seen shapes that look like this, right? Those are complex figures. Okay, but we have all the skills we need to be able to find the perimeter and the area of these kinds of complex figures. Let's remind ourselves again, what is the difference between perimeter and area? What is perimeter? Let's start there. Goni, what is perimeter?
Perimeter is sort of like the outside fence of a shape.
You can think about the outside fence. It is the distance around a figure. Okay, so imagine someone, if you're doing laps around the track, you're running around the perimeter of the field, right? You're running around the edges. What is the units we use for perimeter? Do we use regular units or square units, and why? Daniel.
Square unit.
For perimeter?
Oh, sorry.
Perimeter is just the length, isn't it? So when we're measuring a length, do we use normal units? Okay, but what's area then? The perimeter is the fence or the distance around a figure. What is area? Sanjana?
The amount of square units inside of a figure.
The amount of space a figure takes up. So the area of the field is how much space does that field take up. Now, can we measure space using lines of lengths? We have to measure space using square units because we have to put little squares of units in order to measure it. Okay, so remember, area always uses square units, and perimeter always uses normal units. Here's a word problem. There's a school in Los Angeles called Shane's Inspiration, okay, and they were the first school to build a playground in California so children with and without physical disabilities could play together. That's just some background information. This figure here shows the measurements for a new playing court at a playground. What is the perimeter and area of the playing court? Okay, so the first thing you need to do is to ask yourself, to fully answer this question, how many answers do you need to give? Show me with your fingers. Yeah, to answer this question, you need to have 2 answers because you have to find the perimeter and the area. Okay, so let's start with the perimeter. Now, do you see how this is a complex figure because it's not just one rectangle, is it? It's kind of like 2 rectangles stuck together. So step 1, to solve this problem, you want to divide the complex figure into simple figures, okay? So they drew a line that divides the figure into a square and a rectangle. They added this line right here, right? So now you have a square and you have a rectangle. So let's first find the area because it says find the area and the perimeter of this new playground. So Daniel, what would you do first to find the area of this figure? First, you should draw it in your picture, right? The first thing when you're solving a word problem is you should always draw the diagram.
First, you would split it in half.
Okay, so we already did that. What would you do next to find the area?
Then you would,
So we split it into a square and then also a rectangle, right?
Yeah.
Okay, so how do we find the area of the total thing?
And then you add up the sides of each one, and then like the sides, add up the sides.
So should we add up the sides in order to find the area?
Oh, area.
How do we find the area?
Oh, we need to multiply the base by the height.
So first we split it up into a square and a rectangle, and then we find the area of each individual figure in order to find the total area. So if the square is 9 meters by 9 meters, what is the area of the square? 81 square meters. Okay, now what is the measurements of the rectangle, the blue rectangle? Over here it says it's 6 meters by 18.5 meters. So what is the area of that? How would we find the area of the rectangle? Sapika?
You multiply
18.5 times 6. Good. Let's do it. 6 times 5 is 30. 6 times 8 is, plus 3 is 51. Carry the 5. 6 times 1 is, plus 5. So is the answer 1,110? Abiram, why or why not?
That is, oh yeah, it is 1,110 because there's a decimal point.
Oh. So if we forget to look at the decimal point, might we get the wrong answer?
Yeah.
Okay, so the area of the blue rectangle at the bottom is 111 square meters, right? So how can I find the total area of this playground? What do I need to do, Sawyer?
Well, then you have to add the 2 squares.
Then I add the 2 squares. I add 81 plus 111. So I add this number plus this number. And what do I get? The total area is 192 square meters. Very good. Okay. So are we done solving this problem?
No.
What do we still need to find? Perimeter. Okay. So in order to do that, I'm going to erase what I drew here. The perimeter is the distance around the playground. So let's look. Let's pretend we are going to walk around the entire playground. Let's start at this corner here. If I walk this way, how far have I walked? 9 meters plus, now how far have I walked? 18, because 9 plus 9 is 18, plus this much, 27.5 meters. What about plus this much? How much? 27. We were at 27.5, and we're going to add 6, 33.5 meters. Very good. Now how much have I walked? So we were at 33.5. Let's add one more 0.5 first, which is 34. What's 34 plus 18? 52 meters. Okay, now look carefully. I'm going to walk this whole distance up here to the top. 52 plus 15 is 67. Good. So what is the perimeter of the whole park or the whole playground? 67 meters squared? Very good. The perimeter is the distance around, which is 67 meters.